Hello viewers, welcome to this course on mathematical finance. We will begin the lectures today on a new topic, and this will be module 3, where we will talk about a broader area known as portfolio theory, and primarily we will be looking at two main topics in portfolio theory, namely the classical portfolio theory due to Markowitz and then capital asset pricing model. So, what is a portfolio? So, portfolio is essentially a collection of assets which can be both risky and risk free, and the question that we want to answer when we are discussing portfolio theory is to see that what is the optimal way or the best way by which we can allocate the money that is available to us for investment amongst various assets, and then see that we are achieving a reasonably high rate of return while ensuring that we have minimized the risk. So, accordingly, let us begin this lecture, which is the lecture 7 of the course. So, first of all, we will essentially look at Markowitz framework, and for that we have to look at the concept of risk and return. So, the concept of Markowitz framework was given by Harry Markowitz in early 50s, where he essentially recognized that when deciding on an investment strategy, one need not always look at just the return, but also they need to take into account what the risk is. So, prior to that, there was no appropriate or justifiable or scientific methodology by which one could decide on the choice of investments, and a lot of time it happened that the people went into an investment into a particular security driven by history of good returns without recognizing the fact that high returns typically are associated with higher risks. And Markowitz for the first time reconciled these two concepts of risk and return and sought to strike a balance between these two, namely that you have, while ensuring that you get a good rate of return, you must also factor in the risks that are typically associated with higher rate of return. And these two concepts of risk and return forms the foundation or the two basic pillars of modern portfolio theory. So, let us first begin by talking more about risk and return. So, if you consider an investment in a risky security or asset, then there is always the possibility, as we are seen in case of stocks, that there are losses. Now, we will analyze the potential advantages of spreading the investment into several risky securities, so that the overall risk is under greater control. So, by this we mean that as we have seen in case of stock, which is one of the basic examples of what a risky asset is, if you invest in only one stock, then your essentially your entire savings or investment is at high risk, and if the stock is doing well, then there is no problem, but if the stock is doing reasonably badly, and if the company is incurring losses, then obviously you are unlikely to be getting dividends and as well as capital gains by selling of the stock, and so that means that you are at a risk of wiping out a significant part of your investment. So, it is advisable that you do not put all your money in one particular risky asset if you decide to invest in a risky asset, because it opens up the possibility that a slight adverse situation affecting that one particular asset could in turn wipe out your entire investment. A more pragmatic way of handling this would be for you to make the investment in multiple number of such securities, so that overall the risk that you are facing is to some extent at least mitigated. So, it means that instead of one security, if you decide that you put money in multiple number of risky securities, even if something does not go well with one or two securities, then the effect to your overall investment in terms of an adverse situation or losses is reduced as compared to just exposure to only one risky security which is not doing well. And this is what they say, that do not put all your eggs in one basket, because if something goes wrong with one, you need to have protection that you get from the others. And so, this is basically what forms the backbone of the modern portfolio theory. And the question that we will answer is that when we have a choice of multiple number of securities, how do you allocate our wealth among those securities in terms of percentages of money that you take out and invest in each of those. Now, what we do is that we first begin with one risky security and one time step. So, even though I have mentioned here that in a portfolio theory we will be considering multiple number of assets, just to introduce the notation, I will first begin by considering only one asset, and that too for a single time period, by which I mean that there will be an initial time period t equal to 0 and a final time period t equal to capital T. And once the basic notations are in place, we will then go ahead and extend this in case of multiple assets. So, therefore, we consider the time period to be from the present time which is t equal to 0 to a future time which is t is equal to capital T. Now, if we consider a stock, for example, as a risky security, then we denote the price of the stock at time t to be S of t, and this is for t is equal to 0 and capital T, since we are just considering a single period model. So, therefore, note that under this notation the current stock price S0 is known, but the future stock price is unknown. So, this means that you have two time points 0 and capital T. The price of the stock at 0 is S0 and price of the stock at time capital T is ST. So, this S0 is something that is known and ST is something that is unknown. So, having said that S of t is unknown, we can accordingly make the statement that the return on the stock will be K is equal to S of t minus S 0 over S 0. So, this is the definition of return that you have already observed, that is the extra amount of gain that you make or losses in case of adverse movement. So, S of t minus S of 0 is the additional amount of money that you make, which could be negative, by selling of the stock at time capital T divided by the original investment at S of 0, and you multiply this by 100, then you basically get the return in terms of percentage. So, from now on we will be making use of the notation K for return for the purpose of discussion on portfolio theory. So, that means that in this discussion we assume one time step framework, and this will be extended later. So, first of all, so when you are talking about returns, recall that this return that we had K S t equal to S t minus S 0 over S 0, this K is obvious, since it is unknown, this qualifies as what is known as a random variable. So, when we talk about a random variable, so naturally the next question that arises is what is going to be the expectation of the random variable, and in this case the expectation of random variable is going to be the expected return, or in real terms it means that the return that you expect to get in a single period based on this investment. So, we start off by talking about the first of the two pillars of the Markowitz model, which is the expected return. So, accordingly, consider an one time step investment in a stock with current price of S 0 and the future price of S of capital T. Now, this future price of S of capital T, this is uncertain or unknown and is consequently a random variable. And what is a random variable? The random variable S of t is going to be a real valued function 0 plus infinity from omega, and where omega is the probability space. So, therefore, the return S t minus S 0 over S 0, this is also a random variable. Hence, the expected value of k is E of k. This is sometimes denoted by mu k or even mu, and this will be what? This will be the expectation of S of t minus S 0 over S 0. I can use the properties of expectation to get the 1 over S 0 out, since it is a constant. So, this becomes 1 over S 0 E of S t minus S 0, and this can now be written as E of st, because that is the random variable, minus S0, since S0 is known, divided by S0. And this was obtained using the linearity property of expectation. So, once we have obtained this, so let us look at how you can make use of this. So, you look here that the expected value of the returns is going to be the expected value of S of t minus S0 over S0. So, this can be rewritten as follows. So, therefore, we can rewrite as S of t is equal to, so from here we look at this here. So, from here we get S of t is equal to S0 into 1 plus k, and from here we will get E of st is equal to S0 into 1 plus mu. So, we can obtain the price from the returns or expected returns. So, by this I mean that we can find price as 0 if we know the return and S of t. Likewise, we can find S 0 by making use of mu and E of st. All right. So, in order to illustrate this, let us now consider a simple example. So, suppose we consider a finite probability space. Recall that we had denoted it as omega, with the elements omega 1, omega 2 all the way to omega n, where omega could be possible economic scenarios. That means that the sample space omega or the probability space omega could comprise of capital N number of different economic scenarios or state of the economy. So, we will look at a simpler example later on in the lecture of what I actually mean by the economic state or state of the economy. So, coming back to this, we have this finite probability space with omega 1, omega 2 all the way to omega n representing the capital N number of possible economic states. So, therefore, let us say that the corresponding possible stock prices are, when I am in state are S of t. Now, when I am in the state omega 1, so I will write a superscript omega 1 S superscript omega 1 of t, which is going to be the price of the stock at time capital T if the state of the economy is omega 1. Likewise, if the state of the economy is omega 2, so then the stock price S of capital T will be S superscript omega 2 t all the way to S superscript omega n t, and the probabilities of each of those states of the economy and the consequent stock price will be, so with corresponding probabilities P W I is equal to small p I. So, obviously summation of pi I is equal to 1 to n is going to be equal to 1. All right. So, then what is going to be the expected price at time capital T? So, in order to observe this, let us sort of tabulate all the states of the economy. So, I had omega 1, omega 2 all the way to omega n, with the stock prices being S omega 1 t, S omega 2 t all the way to S omega n t, with the probability P 1, P 2 all the way to P n. Summation pi I equal to 1 to n is equal to 1. Then the expected price E of S t will be obtained by using the usual definition of probability, where we take the random variables and the corresponding probabilities. So, remember that the expectation of a random variable is going to be the sum of the values that the random variable can take multiplied by the probability of that random variable occurring. So, accordingly, what is the random variable? My random variable is S of t raised to omega I superscript omega I multiplied by the corresponding probability P I, and summing this over I is equal to 1 to n. So, in this case the return is going to be, I will denote this by k superscript omega I. This return is going to be as before S of omega I t minus S of 0 over S of 0. So, that means corresponding to each of those states of the economy omega 1 through omega n, since there is going to be a price which I will denote by S superscript omega I of t. So, therefore, for each of them I will have a return k raised to or k superscript omega I. So, therefore, in this case what is going to be the expected value of the return? The expected value of the return in this case is going to be summation, again I use the definition of expectation. Here k superscript omega I is the random variable when I am considering the return. So, this is going to be summation k superscript omega I multiplied by P I equal to 1 to n. Now, we can write this, we can substitute k omega I. So, this will be summation I equal to 1 to n. We can substitute k omega I with S superscript omega I of t minus S 0 over S 0 into P I, and this can be rewritten as 1 over S 0, I separate out the term, into summation I is equal to 1 to n S of omega I of t P I minus S 0 over 0 S 0 into summation P I is equal to 1 to n. Now, what is this term? This term is nothing but expected value of S of t. So, this becomes 1 over S 0 into expected value of S of t minus summation P I is 1. So, this becomes minus 1. So, this is E of S t minus S 0 over S 0 as we have seen previously. So, let us now come to a little bit of discussion on what is going to be the risk. Remember that we had begun by talking about return and risk being the two pillars of modern portfolio theory, and that we had justified that just by looking at the return one should not make a decision, and one need to factor in the risks that are associated with each of the investment. So, accordingly we now look at what is going to be the risk measure or how to actually quantify risk based on the market data or standard deviation. So, the question that we want to answer here is going to be, what would be a suitable measure of risk. So, this is something that we are going to address now. So, accordingly, let us look at the motivation that it is important to understand the scatter of returns around some reference value. So, by this what I mean, say for example, if you are considering a bond with a simple interest and it says that you are basically getting 10%. So, this means that on an average you are getting a 10% return say every year, but with no risk, assuming that you are holding on to your position until the expiration of the bond. However, in case of a stock, you might have returns something like minus 20%, 0% and 50%. So, in this case you see that minus 20 plus 0 plus 50, which is 30%, divided by 3 gives you a return of 10% per year. So, apparently this seems to be identical investments, but in case of bond there is no risk, but in case of the stock which moves from minus 20 to 0 to 50%, you see that there is a great amount of fluctuation in terms of risk. So, this is a simple example of where when the risks are playing an important factor in deciding where you should invest in, because for both the bond and this particular investment your average return is going to be 10%, but in case of the second the risk is significantly higher because of the unpredictable nature and extreme fluctuations in the returns of the particular asset. So, this means that while the average return was 10%, in the first case you were 30% away from the average return at minus 20%, and this means that the extent to which you are fluctuating around this average value plays a very critical role in ascertaining the instability as far as the returns are concerned. And this is what motivates the usage of standard deviation as the easiest one that one can think of as a measure of risk. So, this reference value that we are talking about here, for this, as I have already mentioned, the natural choice is the expected return, and this leads us to standard deviation being considered as the obvious choice to capture the scatter in returns. So, accordingly, sigma k will be used to denote the standard deviation of returns or the measure of risk. So, this is nothing but square root of the variance of k, where k is the return. So, please take note of the fact that k here is the return and not the price of the asset. All right. So, by definition, variance of k is expected value of x minus mu square. Remember what was mu? Mu was nothing but expected value of k. So, this should be actually k, and this can be written as E of k square minus mu square using properties of variance. So, what have we defined now? So far we have defined what is going to be the returns, which is the expected value of k, and now we have defined what is the risk given by sigma k or the standard deviation. So, with this mu equal to mu k and sigma, which is sigma k, we now have the return and risk definition in place for us to move ahead. So, at this point we will start now looking at a portfolio with two securities, and by this I mean two risky securities. All right. So, now once we start talking about two securities, we are essentially moving into the portfolio framework. So, in this framework we consider investment in say two stocks. So, when you are talking about investment in two stocks, it is time for us to introduce the concept of weights to identify the proportional allocation of funds to various securities instead of specifying the number of shares of the security, or in our case stocks. So, by this we mean that when you are looking at a portfolio, it is intuitively it occurs to us that we are specifying the portfolio, and we can go ahead and specify this in terms of number of units of the stocks that we are purchasing. However, it is more customary in portfolio theory and actually more convenient, as we will later see, to identify the portfolio not by the number of units of the stocks that you are purchasing for each of the stock, but rather by the weights of each of them. And by weights I mean that weights are nothing but the proportional investment of the total initial investment that you have allocated to each of those particular assets, notwithstanding what are the number of units of the asset. So, let us now start to give a mathematical formulation for what the weights are. So, therefore, for two securities, we define the weights as W1 is equal to x1 S1 0 over V0 and W2 is equal to x2 S2 0 over V0. So, what are the notations that we have used here? Here the only thing that we are familiar with is S1 0 and S2 0. These are going to be the stock prices for the first and second stock at time t equal to 0. So, let us now go through the notations that we have introduced one by one. So, first of all, let us start off with V0. V0 is basically the total amount available for investment at time t is equal to 0. Next, x1, x2, these are number of shares or units of stock 1 and stock 2 respectively. So, what does this give you? That means that if you have x1 number of stock 1 that you have purchased, and if you have x2 number of second stock that you have purchased, then the term x1 S10 is going to be the total amount of money that you have invested in the first stock. So, this is going to be the total investment in stock 1, and x2 S2 of 0, this is going to be your total investment in stock 2. So, this brings us to the definition that W1 and W2, these are going to be the weights of stock 1 or security 1 and stock 2 respectively. So, by this I mean you observe each of the term. Here I have said that x1 S10 is going to be the total investment in stock 1. That means, this x1 S10 is the total money that you have invested in the first stock, and V0 is the amount of money that was available with you initially. So, that means, out of an amount of V0 that is available to you, you have decided to invest an amount of x1 S10 in the first stock. So, that means, x1 S10 over V0 is the fraction of your total amount of money that you have invested in the first stock, and this is what is defined as the weight of the first stock. And likewise, x2 S20 is your total investment in the second stock, which as a proportion of the total amount that you have invested will give you the weight of the second asset in the portfolio. All right. Now, let us make an observation. See, you observe that W1 plus W2 is equal to, what was W1? W1 is x1 S10 over V0, and W2 was x2 S20 over V0, and this is x1 S10 plus x2 S20 over V0. Now, here as you recall, this x1 S10, this is your total investment in the first stock, and x2 S20 is the total investment in the second stock. So, obviously, the sum of this must exactly match the initial amount of money that you had available for investment. So, that means this sum is going to be equal to V0. So, that means this becomes equal to 1. So, one of the key properties of weights of assets in the portfolio is that the sum of the weights are going to be always equal to 1. So, this is the first observation. Second observation is that typically you expect that W1 and W2 are going to be positive. However, there is no restriction on W1 and W2, and it is possible that either of them can actually end up being negative. So, in case of short selling, one of the weights may be negative, or rather actually in case of short selling this will be negative, and since the sum of the weights must be equal to 1 and one of the weights is negative, so obviously the other weight is going to be greater than 1. So, then we can say that the other is going to be greater than 1. Okay, so what we have done so far, we have looked at the return of an asset in a single period and the risk for it, and then we have introduced the definition of weights. So, now let us look at an example which will show the importance of weights, and in particular illustrate how weights can actually change over a period of time, in our case over a single time period model, when the number of units of the assets in the portfolio can actually remain unchanged. And this will illustrate why it is more logical to make use of the weights to identify or specify the portfolio, instead of using the number of units of each of the stocks or assets in order to precisely define what the portfolio is. So, we begin with this little example. So, suppose that the current stock prices for two stocks are S1 of 0 is 30, that means one stock or one share is 30 for the first stock, and for the second one this is 40. Further, suppose that the amount of money that is available for investment is 1000, and remember that we denote this by V0. Then finally, we suppose that this amount of 1000, which is your initial investment, is split between 600 invested in stock 1 and the remaining 400 invested in stock 2. So, that means what? If I invest an amount of 600 in stock 1, what was the price of the stock? The price of the stock was 30. So, therefore, we can buy x1. So, your investment is 600 divided the price by the price of each of the stock, which is 30. So, accordingly, we can buy x1, which is 600 by 30, equal to 20 shares of stock 1, and x2 is equal to 400 over the price of each share, which is 40, is equal to 10 shares of stock 2. Then from this we can get the weights. So, the weight of the first asset W1, weight is going to be 30, which is the price of each of the stock, into 20 number of stocks you have bought, divided by the total amount available 1000, and this is 0.6 or 60%, and the weight for the second stock is going to be 40 is the price of each stock into 10 number of stocks divided by 1000, and this is going to be 0.4 or 40%. All right. So, now we have essentially the setup at time t equal to 0. Now, let us see what happens. So, the question is, what happens at time capital T? So, suppose that at time t, the price of the first stock S1 of t goes to 35, up from 30, and the price of the second stock S2 of t this falls from 40 to 39. Then what is going to be the value of the portfolio, right? So, the value of the portfolio, remember what was your portfolio? Your portfolio had 20 shares of the first stock and 10 shares of the second stock. So, if you sell them off now, the amount of money that you get for the first stock is 20 multiplied by the current price of the stock, which is 35. So, that is the money then you can get from the first stock, and for the second one, the 10 stocks, you can sell them off at 39. So, this is 39. So, I add them up. So, that means the total value of the portfolio, or the amount of money that I can make if I decide to sell off all the 20 and 10 stocks respectively, this turns out to be equal to 1090. So, that means in this case, the weights, what are the weights going to be? The weight W1 is going to be 20 into 35 divided by 1090. This is equal to 0.6422 or 64.22%. And notice that earlier this was 60%. So, the weights have actually changed. And for the second case, the weights are going to be, weight is going to be 10 into 39 divided by 1090, and this is 0.3578 or 35.78%. So, that means that here this has gone up from 60% earlier, and in the second case the weight has gone down from 40% earlier. So, you see, this is the point that I was making earlier, that when you started off, you bought 20 units of the first stock and 10 units of the second stock, which gave the weights to be 0.6 or 60% and 0.4 or 40%. At time capital T, you still have 20 stocks and 10 stocks respectively, but in this case the weights have changed to 64.22% and 35.78% respectively. So, you see, this is an illustration of why weights play such an important role when you are discussing portfolio theory. So, this means that I can conclude this by making a statement that the actual number of stocks remain unchanged even though the weights have changed. Now, what do we do is that let us reconsider this example or revisit this example again from a slightly different context. We reconsider this example. Now, as before, we start off with an initial investment V0 equal to 1000, but this investment now will mean a long position in stock 1 and short position in stock 2. And suppose we take the weights for the first one to be 1.2. So, naturally the weight for the second asset is going to be minus 0.2. Then x1 will be W1 V0 over S10, right. I am just rewriting the expression for the weights. Remember, it was Wi was xi Si0 over V0 for I is equal to 1 and 2. So, I am just rewriting this, and what is this? This is going to be 1.2 into V0, which is 1000, and remember what was S0? The S0 was 30. So, this is equal to 40, and x2 is going to be W2 V0 divided by S2 of 0. This is going to be minus 0.2 into 1000 divided by 40, and this is minus 5. So, basically you have borrowed somebody else's stock and you have short sold, and you have used that money to purchase some additional units of the first stock for whatever reason. Okay, now what you do next is that, so when the stock prices change to S1 of t to 35 and S2 of t is equal to 39 as before, remember we are revisiting the example, then what is going to be the value of the portfolio? The value of the portfolio V of t is going to be x1 S1 of t plus x2 S2 of t, and this is going to be 40. Remember 40 is equal to x1 and x2 is minus 5, and 40 into the current price 35 and minus 5 into the current price of 39, and this turns out to be equal to 1205. So, you see the interesting thing is that earlier you chose your x1 to be equal to 20 and x2 equal to 10, and now you are choosing x1 to be is equal to 40 and x2 is equal to minus 5. In both the cases you had V0 is equal to 1000, but here in the first case you end up getting your V of t to be equal to 1090, and in the second case you end up getting your V of t is equal to 1205, and you see this is higher. So, this means that you start off with an initial amount of 1000. If you decide to buy 10 and 20 units of the two stocks, then at the end of time capital T your value of the portfolio is 1090. Instead of that, if you had decided to choose to buy 40 units of the first stock and short sell 5 units of the second, then you end up getting the final value of 1205, which is a higher amount. So, that means for different combinations of x1 and x2 initially, or equivalent to different combinations of W1 and W2, you end up getting different values of Vt at different prime points. And so, this brings us to the natural question and wondering, because I have a really wide range of choices of x1 and x2, and the question that we will subsequently address in the course of this discussion on portfolio theory is that what would be the best choice in terms of choosing your x1 and x2, so that my V of capital T is going to be as large as possible. Okay, now let us come to a couple of theorems to illustrate whatever we have done so far, and these are going to be on expected returns and risk for a 2 asset portfolio. So far we have only looked at the weights and what is going to be the returns. So, let us now give it a more general framework when it comes to 2 assets. So, I will state this with a theorem. So, the return KV for a portfolio of 2 assets or securities, remember we are using these words interchangeably, is given by KV is equal to W1 K1 plus W2 K2, where W1 and W2 are the weights of security 1 and security 2 respectively, and K1 and K2 are the random variables which gives you So, these are the returns on security 1 and security 2 respectively. So, these are random variables which give you the return on the first and the second asset. So, the proof of this is fairly straightforward and can be done by just making use of the definition of weights. So, let x1 and x2 as before denote the number of shares of stock or security 1 and security 2 respectively. Then at time t equal to 0, the value of this 2 asset portfolio V0, which is the initial amount of money that is available to you for investment, and this is going to be x1 S1 0 plus x2 S2 0. Similarly, since this is a single time period model, so similarly at time t is equal to capital T, the value of this 2 asset portfolio is V of capital T, and what is this going to be? This is going to be x1 and x2 units of stocks multiplied by the current price of the stock, which is S1 of t and S2 of t respectively. Now, you recall that Si of t is Si of 0 into 1 plus Ki for I is equal to 1 and 2, and so accordingly this can be written as x1 into S1 0 into 1 plus K1, this relation for I equal to 1, plus x2 into S2 0 into 1 plus K2, and this can be written as W1 V0. How do I get this? Again, recall that weight W1 is, or Wi is Xi Si 0 over V0 for I equal to 1 2. That is, I can rewrite this as Wi V0 is equal to Xi Si 0. So, what I am doing here is I am merely replacing x1 into S1 0 with W1 into V0. So, this becomes W1 V0 plus into 1 plus K1 plus the second term likewise becomes W2 V0 into 1 plus K2. So, this can be rewritten as V0 into W1 plus W2 plus K1 W1 plus W2 K2. So, remember W1 plus W2 is equal to 1. So, this will become V0 into 1 plus W1 K1 plus W2 K2. Now, therefore, the return Kv, what is this going to be? This is going to be Vt minus V0 over V0. From using this expression being equal to Vt, Vt minus V0 over V0 becomes W1 K1 plus W2 K2. So, that means the return on the portfolio V, so that means the return on the portfolio is equal to the weighted sum of returns on security 1 and 2. So, this brings us to a straightforward consequent theorem, is that the expected return EKV of a portfolio of 2 assets or securities is given by E of KV is equal to W1 E of K1 plus W2 E of K2. So, the proof is obvious. So, E of KV is going to be E. So, I replace this KV with this expression for KV. So, this is going to be W1 K1 plus W2 K2, and this is going to be W1 E K1 plus W2 E K2 using linearity of expectation. All right. So, finally, we come to one last example. So, let us consider the probability space omega with omega 1, omega 2 and omega 3, where, as I had mentioned earlier, these are going to be the states of economy. So, we identified omega 1 is situation when there is economic recession in the market. Omega 2 is going to be economic stagnation, and omega 3 is a situation when there is economic boom. So, now we consider investment in 2 securities, and we specify the properties. So, let us just have this in a tabular form. The scenarios are omega 1 for recession, omega 2 for stagnation and omega 3 for economic boom. The probability of omega 1 is 0.2, that means there is a 20% chance that there is an economic recession. Omega 2 is 0.5, so there is a 50% chance of a stagnation, and omega 3 is 0.3, so that means there is a 30% chance that there is an economic boom. So, under these 3 scenarios, what are going to be the returns of each of those 2 assets? So, for the first asset, the return K1 is say minus 10%. For the second case, it is going to be 0%, and for the third economic state, it is going to be 10%. For the second asset, the return K2, this is going to be minus 30% in recession, 20% in stagnation, and 50% when there is an economic boom. So, what is going to be E of K1? E of K1 is going to be nothing but the random variables we multiplied by the probability summed up. So, what are the probabilities? Probabilities are 0.2, 0.5 and 0.3. We multiplied by the random variable of the returns. So, the first case it is minus 10%. So, this is going to be minus 0.1. In the second case it is going to be 0%. So, I multiply this with 0, and in the third case this is going to be 10%. So, I multiply this with 0.1 and I add them up to get the expectation as 0.01 or simply 1%. Similarly, for E of K2, I get this as 0.2, 0.5, 0.3 multiplied by minus 0.3 for this 30%. multiplied by 0.2 and multiplied by 0.5 for the third case, and I sum them up to get 0.19 or 19%. Alright, so I have got this expected returns. So now suppose we decide to invest in these two assets. So we specify the weights being W1 is equal to 0.6 or 60% and W2 is equal to 0.4 or 40%. Then the expected return on the portfolio is, you make use of this formula that the expected return is going to be the weighted sum of the individual expected returns. So accordingly, the expected return on the portfolio E of KV, which is the weighted sum W1 E of K1 plus W2 E of K2. So W1 is 0.6, W2 is 0.4, EK1 is 0.01 from here and EK2 is 0.19 from here, plus I add them up and I end up getting 0.082 or 8.2%. So to sum it up, what we essentially looked at is that we first recognized what Markowitz had worked on and predicted in early 50s, that just by looking at the return of an asset, it would not be judicious to make a decision as far as investment is concerned, and accordingly he introduced the notion of risk and gave the idea that the return and risk both need to be considered in conjunction to make a rational decision about how to make a portfolio choice. We next spoke about what a portfolio is, which is essentially a collection of assets. We recognize that it is more logical to make use of weights as a way of specifying a portfolio as against the number of units of each of the assets being used to specify the portfolio. And finally, we define what is going to be the return in case of a two asset portfolio and what is going to be the expected return. So, in the next class we will look at the other component that the Markowitz framework or the other pillar of Markowitz framework, namely the risk, and then proceed ahead to look at Markowitz framework in general. Thank you for watching.